This week on QDL, we explore cobots. Those are robots that work alongside or with humans. And Buckley Brinkman, Executive Director and CEO of the Wisconsin Center for Manufacturing and Productivity, will tell us what they are and how they are being used when we come back. Welcome back to Quality Digest Live. QDL is your weekly look at who and what is making news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest. So industrial robots have been around for 50, 60 years. I believe the first one showed up in a General Motors plant. And you see them a lot, obviously, in the automotive industry, where they are used to weld, paint, transport, move chassis. If you've seen any videos of the inside of a modern automotive plant, you see robots all over the place. They are able to do these tasks more quickly and more efficiently than humans. However, traditional robots, have a big drawback. They are, let's say, human unaware, which makes them dangerous. This is why they are usually walled off. I mean, if you think of it, imagine a robot that picks up a big automotive chassis to position it somewhere, and if a human happens to be in the way, well, that would be kind of messy. So they keep them walled off from humans. But for the past 20 years or so, a lot of research has been done on developing what they call collaborative robots, or cobots, which can work side by side with humans. This has opened up some pretty interesting opportunities for manufacturers. And here to talk with us a bit about cobots is Buckley Brinkman, Executive Director and CEO of the Wisconsin Center for Manufacturing and Productivity. Thanks for joining us, Buckley.
Thank you, Dirk. I'm excited about exploring the topic with you.
All right. So just for people who aren't super familiar with what cobots are, maybe you can just kind of briefly describe what they are, maybe where you'd be likely to see them, that sort of thing. Just kind of an overview there.
Sure. Cobots are, by their name, collaborative robots, and they generally fall into three categories. One are the type known as power force limited robots, where the power behind the arms and the force that they use are limited so that people can work closely beside them. The second are traditional robots that, through new computerization and software, are able to work side by side with humans because of safety features that are built in via software and sensors. And then the third emerging type of cobots are mobile, where you combine a robot with an autonomous base and they're able to do other tasks. Now, where you're most likely to see these are in areas where there are repetitive tasks, but they're not as repetitive as something that demands a full-scale automation, meaning something that's a dedicated machine. Rather, it's a task that might be customized or needs to be a little bit flexible as products change and as demands change. They're also an advantage in that they can take up less space, because now you don't have these massive cages around the mechanism. You can have people close by, and you can actually put the cobots closer together.
And touching on that a little bit. So you mentioned one type of cobot is force limited. So obviously, if it hits a human, the force is enough to trigger it and make it turn off. But it seemed like that kind of technology would be then somewhat limited because it doesn't know whether it's hitting a human or trying to perform a task. So I'm assuming with these, in other applications that aren't force limited, that they're using sensors or something that detect a human is close by and maybe shut down or go into some sort of other mode?
Right. Usually if you're using a traditional robotic arm to do a particular task and you're trying to make it a cobot, what you'll do is create three zones. One's a full speed zone, fully automatic, which the cobot goes ahead and runs at its regular rate of speed. Then there'll be this zone where a human can be present, but it'll react a lot like a force-limited robot. where it will move slower and it'll move with less force than what it would normally if the human wasn't within range. And then, of course, if you get inside the danger zone, usually within a meter or so, the robot will actually stop. So it's done with sensors and lasers, and sometimes also with traditional barriers.
So can you give us some examples maybe of cobots that are working, let's say, side by side with humans, and maybe are there examples where cobots are working, I don't know, sharing a task with a human, if you understand what I mean?
Right. Yeah. And I'll give you one with a traditional robot that is loading an automatic welder. So it will load the parts to be welded on the backside of the welder while the operator is able to do other tasks. So an operator can run 2 or 3 different welders at the same time. Or if there's a CNC machine, it can load the parts to be machined and then put them in the machine, take them out. It allows a lot of lights out operation. We've seen small and medium manufacturers integrate these into their operations and actually bring back small runs of outsourced parts that they've been running with other manufacturers in the area. So it allows them to get a better return on the robot and respond more quickly to their customers. One of the most innovative uses I've seen of a force-limited robot has been an assembly area, where the operator using augmented reality is performing an assembly function. And because of the limitations of the robot can only pick up parts that are easily identifiable. So while the robot is picking up those parts and putting them into place, the human can pull the next part out of the bin and do part of the assembly. So you double the impact of one human at one station.
So that's interesting. So it sounds like the idea here is with combined tasks, human and robot tasks, is you let the robot do what it's good at, which is maybe simple recognition. I know they've gotten more sophisticated. It doesn't have to be simple recognition anymore, but in this case, a simple recognition and a repetitive task, it can do that very easily, very quickly, and free the human up to do something that's a little bit more complex, and then mesh those two functions together.
Exactly. I mean, the humans are very, very dexterous creatures. Our hands can grab things, our eyes can recognize things that a robot can't easily do. And so it's best leaving the humans doing those tasks rather than going through the incredible programming effort that it would take to move a cobot into that space. On the other hand, we don't like doing repetitive tasks or dangerous tasks. So the robot is much more suited for those particular types of applications, or in situations like applying an adhesive or grinding an edge to a tolerance. The cobot can be a lot more accurate and do that more repetitively than a human can.
Now, you mentioned you've seen these in use in small and medium manufacturers, and I guess that surprised me a little bit, because I think when I think robots, I think big and expensive, and I don't see a small job shop using a robot, because I mean, even if they wanted to, it's really expensive, and you have to have certain knowledge. There's robotics programmers and stuff. Do cobots get away from that? Are they more accessible to small and medium shops?
Yeah, absolutely, Dirk. I mean, this isn't your dad's robot anymore. It used to cost $500,000 for a simple robot, and then another $500,000 for the caging and safety equipment to make sure that human and robot never came in contact with each other. With the new technology, you're able to have a robot right here, working right beside you, and moving forward. And small and medium manufacturers are finding these attractive because the price point now has fallen. What used to cost $500,000 now can cost between $25,000 and $50,000. And the programming of them is relatively simple. If you're just moving the robot in the way that you want them to move to perform a given task, and then it will mimic that movement. So we have a lot of manufacturers who are willing to make that investment. And then we have a lot of manufacturers who are saying, look, I won't take technology into the plant or robotic technology into the plant that my normal line people can't adapt to. So it really limits the need for sophisticated programming and other issues that can really drive the complexity or the cost of automation up.
So you just actually touched on an interesting topic. Is anytime we talk automation and bringing automation, no matter what kind of automation is, into a job, let's say manufacturing, there's always this immediate concern about jobs. So who's going to lose their job once we bring in this robot or cobot or whatever the automation is? So is that still a mindset, or have we moved beyond that? Is it still a concern? If it is a concern, how do people address that?
Oh, it's absolutely a concern. I mean, we're stuck in this mindset where we need constant job growth, and we're looking to continually employ new people in the workforce. Well, we're at record low unemployment levels, and our workforce isn't going to grow appreciably in the next 20 years. We're quickly moving from a skills gap to a body gap in this country. So we're going to need robots just to keep the economy growing at a rate that increases paychecks and makes all of us a little better off than we were in the past. At the same time, if this technology causes us to lose jobs or jobs to shrink back, it will be the first time in history. I mean, there's never been a technology that's been introduced that's actually reduced the number of jobs. Every time we've introduced new technology, it's always increased the number of jobs that are created and available. They may not be in the same fields, but growth has a way of needing people to execute it. And we're a very long way away from machines running the earth here. There's still just a limited application to where they can perform practically on a day-to-day basis without human intervention. In fact, what we're finding is that the best operations, whether it's medicine, whether it's finance, or whether it's manufacturing, are where the computer works side by side with the human. Neither performs as well alone as they do as a team.
And since you touched on the skills gap, so I do want you, and we'll come back, we'll finish up on the cobots here in just a second, but I did want to sidetrack a little bit in terms of what the MEP, the Manufacturing Execution Partnership, what that is doing in terms of training up and helping to close the skills and the body gap that you just mentioned. How does MEP play into that?
Yeah, we do a number of things. First of all, we're very good at leveraging the resources that are already there. So in Wisconsin, we have a very strong university and technical college system. So when we're talking about the basic technical skills, we can engage with the ecosystem that's already there on that front. Where we're extremely effective is when you get into a small or medium manufacturer, making sure that manufacturers understand the trends that are coming and that they're engaging their employees around them. Because in this day and age here in Wisconsin, we're below 3% unemployment. So if you treat your employees as being an interchangeable part of the company and relatively disposable, if you get rid of Buckley because you don't think he's a good employee or he doesn't have the skills you need, just beware that there's not another person to replace him at the front door. So we help companies come to grips with how do we make sensible investments in training, how do we configure the workforce so that we get the most possible productivity out of them, and then how do these manufacturers integrate new technologies like cobots in a sensible way in their operation.
Okay. So back to cobots here. I'm just going to finish up with this. So what is the current state of the technology, and where, as far as you know, where is it going? Kind of what's the next step?
Yeah, I mean, the current state of the technology is that we've seen really dramatic improvements in sensors, both visually and in terms of force, so touch. So those capabilities have really improved, and the costs have plummeted. So you're seeing Moore's law affect sensors as well as computing power.
Sure.
And computing power has just become very, very cheap. So it's enabling us to start to combine different technologies. And as the cobot is working at the end of the line, it can, with improved sensing, it can take on more and more tasks. The computing power allows the programming to be more powerful and more friendly. And then where it starts getting really interesting is when you start integrating it with other Industry 4.0 technologies like artificial intelligence or connected systems or 3D printing. When you start making those combinations, you start getting some really powerful leverage situations. And it's interesting because it really takes a new kind of thinking from manufacturers that we engage with, because you now have to look at your entire environment. I'll give you a really quick example. The power and force limited robots are designed to move not fast and not hit with any kind of intensity. So you can bump up against it or it can bump up against you and cause no lasting damage. But consider an application where you're stacking razor blades in a box or having knives in a box. No amount of slow motion or lack of force is going to make that a safe operation for a cobot application. So you have to be really aware of the entire environment and matching up the particular cobot application with what the task is you're trying to get done.
All right. Well, cobots, it's a fascinating technology. All right, Buckley Brinkman, Executive Director and CEO of the Wisconsin Center for Manufacturing and Productivity. Thanks for joining us today. Appreciate it.
Thank you, Dirk. I appreciate the time.
Hey, no problem. All right, and that is it for our show today. And as usual, if there is someone or something that we'd like to see on the show, let us know. You can send your ideas to us at qdl@qualitydigest.com, and I will do my best to bring those people or things onto the show. So thanks for joining us today, and we will see you next week on QDL. So long.